Right. Welcome to lecture 9. Okay. Any questions? So I put an iClicker questions here. The idea is to give credits to people who come on time. So what is the answer to this? A. Okay. So the materials from today's lecture will not be on the exam. Will not be on exam 1. It will be on exam 2 and the final exam. Okay, to be exact. How was your exam 1 in organic chem 2? Good. That was my favorite class. It's basically a series of puzzles. Love it. And my lab actually makes it is actually useful, surprisingly useful. I'm surprised. As a physicist, I thought that thing is useless because when I was taking biochem, I thought that I could use those reactions to memorize, let's say, glycolysis. Apparently, that thing didn't help much. But my lab used it all the time. We synthesize DNA. We put many small molecules to DNA. We synthesize peptides DNA by ourselves. Any other question? Yeah. Sorry. Yeah. You don't have to do it. Do you have any question? Okay. How about you at the back? Do you have questions? Can you please, like, just for like 50 minutes, just, right? Thank you. Just be respectful to your friends. Some of their parents work like 3 jobs to send their children to SU. I mean, true story. Okay. Any other question? Good. Okay, so let's close the iClicker question. I'm gonna give A as the correct answer. The answer to study guide will be posted soon, if I remember. So if you don't see it by the end of the day, you should email me. I will be driving to LA, but I can stop and upload the answer. Okay, so the topic, I think the last time, meaning last Friday, we finished the lecture by briefly discussing about energy per unit volume, which is small u. Anyone still remember? This one is part of exam 1. It's 1/2 epsilon E square, something like that. So basically, this is a nice formula, one of my favorite formula. So if there is electric fields, whether it's in capacitor or anything, there is energy in that volume. And towards the end of the semester, we will use this formula, the exact formula for calculating the energy of electromagnetic wave, such as lights. So it's amazing that a formula that we derive from just studying 2 plates is applicable to everything that has electric field. I find that really amusing. All right, so next is I show 2 panels there. One is it's basically a cross section of a wire. So wire, typically we draw it as a cylinder, and wire, they are made of metal, so the electrons can freely move. All of you remember that, right? Electrons are the ones that move, not the protons. So without chemical energy, these electrons move at random location, at random orientations, and the average of their movements is 0, because any electrons that move to the right, you can find different electrons that move towards the opposite direction. And there are Avogadro number of electrons in a conductor. Okay. So next is the second panel is electron with a bias, meaning let's say you can put a battery. So this is a symbol of battery. So you read this in perusal. So what happens if we connect battery like this to a conductor? What happens? Did I assign the right section of perusal or? So this is actually, when I was your age, I didn't appreciate this concept as much because the math is so easy, as you soon will see. It turns out that there is electric field in this conductor. Okay, is that in contradiction what we learned so far? Yeah. So so we call this not an ideal wire. There are some impurities. That's the reason why there is electric field, and each charge, maybe E, we can put each electron has charge small e, okay, and has mass, the mass of electron. So what is the force? The force is ma. So force is E times capital E, and the acceleration is what? The charge of the electrons times the electric field divided by the mass. Okay. So what is missing here? What is not correct with what I teach you so far? I guess I need to ask I need to articulate my question better. If the acceleration is not zero, you can expect, if you wait long enough, all of these electrons will travel at the speed faster than speed of light, because the acceleration goes forever, right? So why the electrons in these cables, in those cables, they don't have infinite speed? So you put energy, you put electric field, there is no opposing force. So far, that's where we are going to. One would expect that electron goes to infinite speed. But it turns out that these electrons collide with what? With what? With each other. That's a good guess. But there is another guess. With nuclei and other impurities. So the nuclei, so there are nuclei. I'm not going to draw the nuclei. It's actually drawn here. And the nuclei collide with electrons. The nuclei also yeah. So basically what happened is, and this is not going to be in the exam, this is actually fairly advanced. So when you accelerate, the speed over time goes to, it's linear. Speed is equal to a times t. And then when it collides to electron, the model says that it goes to 0. And then it increases the speed again at the same slope, maybe longer, and then hit another nuclei, something like this. The name of the model is Drude model, which will not be on the exam. Okay. Just to continue, since we have time, it turns out that the resistance is a function of temperature. Okay. Because let's say you have nuclei and the electron goes like, let's say it bounces another nuclei. The protons and neutrons, they vibrate. And the higher the temperature, the vibration is more significant and the resistance increases. There is another extreme, which is at 0 Kelvin, like close to 0 Kelvin. If you have a nice periodic structures or crystal, the electron will have very little resistance. So this is like I put chairs in this area, and you can just run really fast, right? But if each chairs vibrate or like jiggles by a lot, at some point you will hit the chairs and stop and then run again. Okay, so those are the explanation of the slide. Any questions? Okay. Next is there is a concept of electric current. The electric current is given by, this is taken straight from your textbook, I think this formula, so the notation should be correct. So if you watch, let's say you're here, you watch this, you watch at this point and count the number of charges that pass through that area divided by delta t. That's what we, this parameter here is called the electric current. The unit is coulomb per time or per second or ampere. Okay, let's just continue. I can easily talk for the whole lecture about this. All right, so just to wake you up a little bit. So we have this iClicker question. When a current flows through a metal wire, the moving charges are 20 seconds. Five more seconds. 3, 2, 1. Okay. So what is the answer? The answer is B. So 80% of you got it right. So protons don't move, but it's a good segue to discuss about the direction of the currents. So if we have a battery here, symbol of battery is typically 2 lines. And then there is typically we put resistor. Then the direction of the currents is actually the direction of, or the direction of the current is given by this arrow. But actually what happened in real life is that the electrons move from the negative electrode to positive electrode. So the movement of subatomic particles or electrons is this way. Nothing moves along the direction of the currents. But we are stuck with this convention. So even in advanced class, we use I instead of electron. Okay. Is there any other? Okay. So let's put numbers. So on Monday, you need to be comfortable with putting numbers. The equation is still delta Q divided by delta T, but this is more like the units. So the question is, suppose 1.5 moles of electron are passing through a device every hour, not every second. What is the currents through the device? Okay. And you can work with your neighbor. for 1 more minute. Anyone can help me? 1 coulomb is what? 1.6 times 10 to the minus 19. Okay, good. So 1 electron is. All right, 20 more seconds. All right, 5 more seconds. 3, 2, 1. Okay, so let's see your answer. I think that's right. So first, these are the type of units that you need to know. Some of them are given on the cheat sheet. Like one electron has 1.6 times 10 to the minus 19 coulomb. But you should know 1 hour is basically 3,600 seconds. This is and then cosine, sine, theta. You should remember that. And then 1 mole is 6 times 10 to the 10 to the plus 23rd. You should know that. Okay, so I is equal to delta Q. Delta Q is 1.5 mole of electrons. So 1.5 mole, we need to convert to number. And then we need to put the charge 2 coulomb. So the coulomb is 1.6 times 10 to the minus 19 coulomb. Delta T is 3,600. You cannot put hours. You should use seconds. And I did this last night, but I forget. So the answer is D. If you put the number, you should check my calculation here on the slide. When you put the number, the answer is D. So more than half of you got it right. So you guys are ready. If you miss this question, don't give up. You can still study until Monday. All right. So let's talk a little bit about battery. Battery is important. If you have, in all devices, Tesla or my cell phone, your cell phones, it has battery. So what is battery? So battery, maybe it's not a bad idea to talk about capacitor first, since it may be useful for your exam. Battery is more than capacitor. It has chemical reaction inside between the plates. So let's say if we have capacitors, right? Capacitors has plus Q on top and minus Q at the bottom. And let's use the simplest capacitor, which is capacitor with vacuum. Okay. So there's 2 charges. So this positive charges and negative charges, they're attracted toward each other, right? But because there is vacuum, these 2 charges cannot move beyond the plates. But in electric circuit, let's say we have resistor here, which we will discuss. This positive charge can move, the current can move. I mean, you all know that the things that move are electron, but the current can move. And then you get nice and then you get a current. And we will study this in probably 3 lectures. The shape of the current is exponential. So initially high currents, and then it approaches to, what is exponential? It approaches to 0. And then how long does it take to completely dissipate or completely eliminate these charges? Huh? Yeah, infinity. So exponential decay doesn't go to 0, meaning it approaches 0, but it will never reach 0. This is because the movement of the charges is driven by the number of charges here. So as we decrease the number of charges here, the flow of charges will be slower. So this is one way this is one applications of capacitors to flow charge and also to keep charges. This is why when you maybe even in your cell phones, well, probably not in your cell phone. In the old days, there is a warning sign that says, "Do not bring your device to bathtub." That thing is not because your roommate needs to use the bathroom, but if you bring your computer, your laptops to bathtub, and you drop it, you will electrocute yourself, despite the laptop is not connected to the bathtub. And in some devices, they say, please do not fix or repair your cell phone yourself. Part of it is because that could be dangerous, but there is another sociology, economic reasons behind that. Okay. So that's even right now, people still a few research labs are working on capacitors that dissipate current slowly to replace battery, but that thing is not common. Okay. So right now, let's put chemical energy in battery. It looks like a capacitor, but it's not. So this one, there is electric potential. I think your book uses forces. That if there is charge, it would bring the charge from top to bottom. Basically, what chemical reaction in battery does is it opposes this electrostatic. Let's just Fe. So it can keep more positive charges on top and negative charges at the bottom. So you're seeing this slide. The analogy that I like to make analogy between electromagnetic and mechanical world. I don't ski, but this is let's say this is a ski resort, and this is you, and you ski. So this is like electric current. So instead of electron, as your student can ski, and along the way, let's say it hits many trees, and then it stops. So throughout the way, there is F gravity. So this is similar to what happened if we have resistors here. The trees are the resistors, okay? So without putting any energy, this is the end of the fun, right? But people who build ski resort, they are smart. They have a ski lift. So this is ski lift. So with ski lift, one person or a group of people can go back to the top. When it go back to the top, the gravity still does work. This is relevant to exam 1. but the work is negative. The positive work was done by the skill lift. So using this analogy, the battery acts like a skill lift. The idea is so you can skill lift. The idea of the skill lift is so the customers can ski over a long period of time and spend more money. Here, the idea of having battery is so we can do more work. The circuit can perform more work. Okay. And the nature of the battery, the energy of the battery is chemical energy. Good. Any questions? This is part of your perusal. Quick question: has anyone done electric circuit before in your high school? Good. A few of you. So it will be easy, but for the rest of the class, I will cover everything to make sure that no one is left behind. So next, let's talk about voltage is equal to I times R. This is a famous equation. We call it Ohm's law. Ohm's law is V is equal to I times R. It's my friend's favorite equation. So while I erased the whiteboard, when I was your age, I was part of a band. So and the lead guitarist, his name is Riff, and that's not his stage name. It's actually his real name. So Riff, and both of us are nerds basically. So Riff is so instead of V is equal to I times R. We always think his name means R times I is equal to V. He plays guitar, I play keyboard and mouse and trackball. Anyway, no, I also play guitar. All right, so Ohm's law is V is equal to, so R, anyway, let's use more standard Ohm's law instead of Riff. So V is equal to I times R. V is a voltage, I is the current. So if we have our favorite circuit, the simplest circuit in the world, which is a battery and a resistor. So the voltage drop around the voltage drop along a resistor, if we have a voltmeter, this volt here is equal to I is the current, V is the voltage of the battery. Many books likes to call this EMF, and we can discuss it maybe after the exam because it's a bit delicate concept. So to calculate the voltage here, we can use Ohm's law. Okay. All right. Any questions? Let's skip these slides. This is when we discuss resistors in series and parallel. And we can revisit EMF after the exam. Okay. So I have this iClicker question. I hope you've been paying attention. So this is a conceptual question. The question is, what is the purpose of the battery in an electronic device like a cell phone or your laptop? One is to provide the charges that make up the current in the circuit, or B, to provide the energy that enables the current to flow through the circuit. and C is both A and B. All right, 10 more seconds. 5, 3, 2, 1. All right, so what is the answer? Okay, good. Maybe maybe I need to do it more slowly. So based on our discussion, the main reason why we have battery is to provide energy. So the current can flow through over and over again. So the answer is B. Okay. And the reason why there are charges is because we put energy. So the correct answer is B. Okay. Good. Okay. This is another conceptual question. Let's see if your answer reflects my teaching ability. So I'm curious to see whether you get what I try to explain. So Ohm's law, or RIF, the figure shows conventional current passing through a resistor R. The arrow shows the direction in which the conventional current is flowing. So one thing that I forget to mention is that the polarity here is positive and here is negative. So at this point here is at higher voltage than the negative point. So this is higher voltage and this is lower voltage. And current flows from high voltage to low voltage. Okay. Similarly, like if you drop a ball, it goes from high elevation to lower elevation. So there are 5 options, and there could be more than one correct choice. Okay, so more than one. So the multiple answer. Okay. All right. You can discuss it with your friends. You want to do it together? Okay. You can modify your answers. Okay. So first, the charges are moving slower at point B than point A. Is that correct? Who says it's correct? The charges are moving slower at point B than point A. So if the charges move slower at point B, okay, first, this is a part of circuit. Because if it's only a resistor, there is no current. So maybe a more proper drawing is like this. I didn't have space to draw the whole thing. So if the charges move faster here than here, okay, then if you wait at any given time, there is buildup of charges. And then if you wait, I don't know, at the edge for a very long time, edge of the universe, let's say, then there will be infinite charges here. So the speed of the current is actually the same. So A is not the answer. Good. The electric potential, so B, the electric potential is lower at point B than point A. B and A. Yeah, so it's B is one of the answers, or could be the only answer. Okay, so on the exam, if I say there could be more than one correct choice, it doesn't mean that there will be more than one. Okay. Next is the electric potential is higher at point B than point A. That's not the answer. The current at point B is the same as the current at point A. It's, yeah, so the current here is the same. For a simple circuit, soon, you know, we will do multiple loops, let's say, I don't know, something like this. Then the current may not be the same. And there is battery, I don't know, battery here, battery here. But for a simple loop like this, the answer is yes. The answer is like the current stays the same. And then the final option is the electric potential at point B is the same as the point A. So that's not correct. If that's the case, then there is no currents. Okay. So the answer is B and D. So let me, you know what? It's a free credit. I'll accept F. How to do this? I'll figure out at the back end. Okay. Any questions? Okay. So and then finally, if you touch resistors, you will feel heat. Okay. This is because resistors, the way it stores energy, well, sorry, capacitors store energy by keeping charges on both plates. But and then in the middle of the semester, you will learn about inductor that store energy in the form of magnetic field. But one thing that probably you pick it up from perusal is that resistors, they don't store energy. They dissipate energy. This is why when you touch resistors, you feel heat. And many, in the old days, many stoves are basically resistors. Okay. So the power, so what is power? What is power in physics? Power is energy divided by time. So energy per unit time, the unit is watts. So for resistor, here is power that resistor dissipate is equal to V times I times V. It's the same thing. V times I, and then V using Ohm's law is equal to I times R. So this one is equal to I square times R, where I is the current and R is the resistance. Okay. So let's just briefly. I'm gonna tell you the roadmap for what we will do after the exam. So we will learn about, similar to capacitors, resistors. You can combine them into series or what, parallel or both, right? And on the exam, you will be asked to solve the equivalent, to find the equivalent capacitance or the voltage drop of capacitors in series, parallel, or most likely combination. Either there will be one or two questions on that. So the arrangement on the left is in series, the arrangement on the right is parallel, and then what we will learn also to solve the currents, for example, or voltage drop of a complex arrangement. And there will be tricks for that. The name of the section is Kirchhoff's law. All right, so we have 10 more minutes. Either I can let you go early or you have questions about the exam. Huh? Yeah. Can we, no. So the exam ends until the energy density of capacitor. Okay. Good. And then I don't plan to be here. I plan to be on campus, but as you West, your LA, one of them at least will be here if you want to take it here. I'll be on Zoom, so if he has question, he can ask me. But my recommendation is for you to do it here. So if you have any questions, the LA can answer your question immediately. All right, I'll see you on Wednesday, and good luck on your with your exam 1.